All right, guys. Very good morning. Very good evening. Can somebody confirm me? Is my voice is clear and you guys
It's
can
clear.
able to see my screen?
Yes, it is visible and clear.
Yes, sir. Yes, sir.
All right, great. Okay. Let's quickly recap what we what we discussed yesterday, and then we'll continue further discussion on the rack architecture and rack networking and the installation and the type of database and the cluster resources and local resources and cluster startup sequences. Couple of topics related to RAC. So we'll explore on those topics today. Right. So we started with the introduction. We started with the introduction about myself because I'm the one who is gonna uh, take this entire course. I just explained or briefed about me and then my overall experience and my areas of expertise. And then followed by we started explaining or discussing about the course curriculum or course content, what all topics will be included on this course. That's your course curriculum. I'm gonna just reopen it one more time here. This is there in my blogspot.com, malik034blogspot.com. You can go ahead and then visit the course curriculum and review the course curriculum. So I'm just gonna ping that link in the chat as well here. You can take as a reference. Right, so yeah, I'm not gonna brief again. You can go ahead and have a look on this blog here. So what is included in this course? Introduction to the cluster architecture, Linux installation configuration, networking, and cluster installation, rack installation, and disk group creations, and ASM administration, and ASM disk group administration, and your clusterware administration, rack database administration, and your clusterware maintenance, administration, resource maintenance, and rack database administration and its content, and backups and recoveries of your rack database, again, which includes various scenarios, cloning and all, and your listeners, TNS, and configuration of your listener and TNS for your CDBs and PDBs, and multi-tenant architecture, CDBs and PDB, cloning and RMA and backup, restore recovery of your multi-tenant database, and your ACFS, ASM cluster file system, RAC one node. Somebody asked yesterday a question about RAC database and RAC one node database. We're going to talk about here. And patching, the patching of your GI home, Oracle home, database, OPatch versus OPatch Auto, rolling, non-rolling, hybrid patching, and upgradation. Somebody had a question yesterday about upgradation, right? We'll be covering upgradation 11G to 19C, 12C to 19C. There are various method of database upgradation, DBUA, GUI method, manual method, silent method, command line, SQL prompt upgradation, shell script upgradations, and your Perl script upgradations. So there are various database upgrade methods. We're going to talk about them. And then node addition and node removal, cluster expansion, all those things covered here. And you're converting standalone database to RAC database, and followed by some extra topics like resume writing, cover letter preparation, interview questions and answers, and mock interview. Right, so that's pretty much about what this entire course is about and the course curriculum. In case like there are a couple of questions around this yesterday, and also many people are pinging me yesterday. Some talking about some extra topics like Wallace, TD, standby database, and all those things. So those few topics will be covered as a extra topics after the end of the course. So for this particular course, this is a pretty much what we form the course content. But anything apart from this, extra topics and all, will be taken it as the extra class based upon everyone's interest. All right. So that's a course curriculum, what we discussed yesterday. And then followed by, we talked about the course durations, course timing, and the fee structure. So again, all will be available on this particular link here. Again, I'm going to share it in the Zoom chat. You can take it as a reference, or you can reach out to me on my cell phone or my WhatsApp number. Right, I can quickly open this course curriculum. So this upcoming batch, so what we are started here. So 6th July, what we are starting this new batch. So you can always refer this upcoming batch details. So then you can go to this Google doc, which talks about the course curriculum, course content, course duration, and fee structure. So whatever we are conducting yesterday and today, Saturday and Sunday in IST time zone, 8 a.m. to 10 a.m. are the demo sessions. And Eastern time zone in EST time zone, it will be 5 July, 5th July to 6th July. That's the Friday and Saturday. 10:30 p.m. EST to 12:30 a.m. EST. It will be in the midnight, 2 hours for the EST time zone. So this is the same link what we're using it for the demonstration, and the RAC course curriculum what we just explained or briefed about it, the course curriculum. And our actual class is going to start on 13th July. So if I get my calendar page here, let's get it over here. Give me a second. All right. So whatever we talked 06th July and 07 July. So these are demo sessions, followed by the next weekend, that will be 13th July, Saturday, is the one where we're gonna start our actual batch. Let's say here, if I open this Google Calendar here, so whatever we talked about 6th and 7th are the two demo sessions on the weekend, and followed by 13th is the what we're going to start our actual course. 13th, it's a weekend batch. 13th July, what we start the regular classes. So this particular course is going to be of 5 weekends. If you see here, so 13th July, Saturday, we are starting this class, and that will be a 4 hours on the weekend, 4 hours on Saturday and 4 hours on Sunday. The timing is going to be 8 a.m. IST to 12 p.m. IST. In Eastern time zone, it will be at 10:30 p.m. EST to 2:30 a.m. EST. So there's a slight difference here between the EST and IST. So 13th July, Saturday, IST, 8 a.m. IST to 12 p.m. IST. But when it comes to Eastern time zone, that will be 1 day behind for them. For them, it will be a 12th July 2024, that will be Friday, that is in EST time zone. And for them, it will be a 10:30 p.m. EST to 2:30 AM EST. Right, that will be for Eastern time zone. So there's a slight a time difference and the date difference. So for IST it will be Saturday and Sunday, and for EST time zone it will be Friday and Saturday. So this is a weekend batch, only Saturday Sunday. We'll be covering Saturday Sunday, 4 hours on Saturday and 4 hours on Sunday. 8 a.m. to 12 p.m. IST, 10:30 p.m. EST to 2:30 a.m. EST. So the 5 weekends we should be able to complete. So if you start on the 13th weekend, 28th weekend, and 27th weekend, and August 3rd weekend, and August 10th weekend. So we should be able to complete by August 10th and 11th. So if it are any extra topics or extra content need to be covered, so we'll take one more weekend, 17th and 18th, and then we try to wrap it up this entire course. Right, so that is about the course duration and the course timing, and this is the 5 weekend. And coming to the course fee structure, this will be of 15K INR Indian rupees or $185 USD. So this course will be conducted live classes over a Zoom link, and the database version will be of 19C. So with that, we got couple of registration yesterday. So you can feel free to ping me on my WhatsApp number or on my cell number. You can ping me on my WhatsApp number +919880616848, or on the same WhatsApp number, or we have other number as well. So you can feel free to ping me or call me for further discussion on the course payment and how we can proceed for the registration. I can guide you through that. Right. So that's about the course timing, course duration, and fee structure. And the requirement, the minimum requirement for this particular course, you should know the basics of your Windows, Linux, and basics of your database knowledge and the SQLs. So if you know these basics, then you can proceed with this RAC course, because so we are gonna cover a lot of the internals to the RAC and database architecture, and it will be purely of the networking stuff. So if you don't know Linux command basics, you don't know the SQL command basics, you don't know the database basics. So whatever I'm going to explain about RAC, internal architecture and all those things, you'll not be able to catch up the things, and you'll be get confused, and you'll be lagging in the course journey. So before registering for this particular course, you make sure that you have all this knowledge, and then go ahead and register for this course. And main important thing is your hardware requirement, because if you want to do a hands-on, if you want to listen, don't want to do hands-on, again, this course is of no use. For all the DBAs, the hands-on is very much important and mandatory. Then only you can understand the concept in details, and then that will be of, permanently, you can remember the concept and the things only when you do a hands-on. So in order to do that hands-on, you should have your hardware. You should have your laptop and desktop with a minimal of 20 GB RAM and 150 GB SSD hard disk, so that you can easily set up your lab using VirtualBox. Once you set up a lab on your laptop, then you can do any practice, and you can do or simulate whatever scenario you want. So that is about the minimum requirement what this course needs. All right. So with that, what we started with explaining about the Google Drive. So let's quickly open and show that a Google Drive link, what I was talking about. Right. So the link one is about the course curriculum, the course material. The course material which has all the content. Let's say I can open it over here. This is about the RAC course materials, which has all the PPTs, all the RAC book, all the ready VMs, all the ready labs. Everything will be available on the Google Drive here. That's the link one, what we explained yesterday. And the link two is about softwares and automation script. So softwares and automation script. So that will be for, again, if I open that one here. So this is for your softwares and automation scripts and interview questions and all. Like let's open this interview questions. So this interview questions has everything, whatever needed for database, RAC, and all those things. So there will be thousands of questions are written over here. So you can just go and then prepare all these questions before you appear for any of the interview. Great. So that is your second link. And the a third link, the previous batch recording. So you have all the previous batch recording so that you can go and then watch them in advance so that you can be well prepared before attending the live classes. Let's say if you go here, these are the previous batch recordings. So we have recordings as well as the whatever the notepad we are going to use it. For example, if I go over here, the installation part, the VM setup, say disk creation, networking, if I open that notepad along with that, so whatever the command I'm executing on my lab, all those commands output, everything will be saved over here. So that you can, while watching the recordings, like let's say if I open these recordings, so whatever recordings you want to watch here, the previous batch recording, while watching this one, you can go and then practice that whatever the command I'm typing it on the notepad. Right. So this is just you're gonna watch the recordings and then you're gonna start installing whatever I'm gonna teach on the command line here. Right. So that is like preparation by your own well in advance so that you can be more interactive and ask more questions during the live classes. Right, that's for the link 3 previous batch recording. Link 4 is a current batch recording. If I open the link for here, probably who are registered for the course, they might have got access on all these 4 drive. Otherwise, I'm gonna grant it by after today's class. So if I open this one here, right? So this is this is for the current batch. That is for the link 4 here. Link 4 is the current batch recordings. So current batch recording, if you see, this is the yesterday's demo sessions, what we discussed, and the same demo sessions, whatever we use the notepad, will be uploaded over here. So that's the importance of Google Drive. So these Google Drive links will be available forever, and even you can go and then download it locally on your laptop. No restriction on that. All right. So that is the Google Drive access. And similarly, we talked about WhatsApp group. So WhatsApp group, we already added those students who are registered and all the communications are happening over there. So few students are already started watching the previous batch recordings and they started posting their questions or queries or whatever the doubts they have it. So that's a single group where you can get dedicated support, and we have this WhatsApp group for only registered students. So you can use this WhatsApp group for clarifying your queries, questions not related to only this course, and even your work related endowment issues, whatever you're having issue or stuck with some activities and having some challenges in the current project or the current organization, you can feel free to post any questions over there. Or you are attending for some interview and you want to track that, and there are some challenges questions asked in your previous interview and you're unable to answer them, you can post those questions. So I'm going to help you on that, clarifying those questions or doubts. Yeah, and then this is a dedicated WhatsApp group. It will be there for lifetime support. Yeah, same as your Google Drive access, which will be there for lifetime access. And based upon that, how you can keep your WhatsApp group active. then this group will be there forever. If there's no activities and the group will not be active, and it will be deleted if nobody is interested. All right. So that's about the Google Drive and the WhatsApp group, what we discussed, and followed by we started with some concept of RAC, and we started with the discussion of standalone versus RAC, and what are the advantages and disadvantages of the RAC. Right, so we'll continue further with the discussion on those networking, RAC architecture, RAC cluster resources in next few minutes. So I'll take a pause for a minute if anyone has any questions so far on the course curriculum, course content, course duration, fee structure, or the payment process. Feel free to ask. I'll pause it for a minute before I continue with the further technical discussion. All right. Give me a second. If no questions, then I can continue with the further discussion here. All right. So I'll take it as a no questions, then I'll continue further. What I'm going to talk now, let's say, what are the types of databases? Right. So like say somebody asked what are the types of databases? A standalone RAC. Two types of databases, standalone and RAC. We have a standalone without ASM, and we have a standalone with ASM. RAC one node database, RAC database. So we have two types of databases, a standalone database and RAC database. And in standalone, we have standalone without ASM, where database is running under file system. We have standalone with ASM, where your database is running under ASM. So as part of my database course, if you are attended my database course, and so we are going to cover these two types of databases, standalone without ASM, standalone with ASM. As part of my RAC course, we are covering this RAC one node database and RAC database. So just to show you in my lab here, so I have this lab 1, Oracle lab 1, and we have this Oracle lab 2. So in this Oracle lab 1, if I do PSFNF grep S1, so I have this at DB. This is a standalone without ASM. So standalone without ASM, you can see this lab here. So standalone with ASM, here we have this lab 2. So we have this ASM and database is down. Let's quickly start my database. TestDB. Let it start. And then we have this node 1 and node 2. This is my rack. Right, so rack meaning if I do ps-ef grep s1, so I have this asm1 here, and I have ps-ef grep s1, I have my asm2 here. So all my second node databases are up and running here, and my first node, all the databases are down. I brought it down because of some maintenance yesterday. So here on my test DB and ASM. Right, so we have standalone without ASM, standalone with ASM. So this is your file system and this is your ASM. We have two types of databases in standalone. In RAC, we have two types of databases, RAC one node and RAC database. So if I go here, my node 1, everything is down, so nothing is running. And my node 2, all the databases are running here. So one way to bring down your databases, let's run. I'm going to just bring one database. Let's say CDB2. I'm going to go with the CDB1. I'm going to use srvctl start instance hyphen I CDB1 hyphen D CDB. Okay, resource is not done. So this particular server has a limited resource. I need to, it is under maintenance mode. I cannot start my database. I need to bounce my cluster and then do some maintenance. So don't worry, I'm not gonna touch this node 1 for now. Let's go to node 2 only. So what is a difference on this lab 1 and lab 2? So in the lab 1, this is my Oracle lab 1. This is my Oracle lab 2. And in this lab 1, your database is running under file system. And in this lab 2, your database is running under ASM. So I can quickly connect to my .env devdb SQL plus slash as SDBA. So go to lab 2 SQL plus slash as SDBA. If I do select name from $, control file, all my control files are on data disk group and ASM record disk group. These are ASM storage. If I run the same command on my devdb here, all my control files are stored under my OS file system. Select name from $, data file. All my data files are stored under OS file system. And the same command if I run under this lab2 testdb, all my data files are stored under data disk group. That's a ASM storage. That's the only difference between your a standalone database with ASM and without ASM. Standalone database without ASM is called file system database. Standalone database with ASM is called again standalone database. But this is typically we call it as a Oracle restart server. Why Oracle restart server? Because whenever your database is killed, automatically ASM will bring up that database. Meaning, if I go here, PSFNF grep S1, I have this testdb database. I'm going to kill that one. So my database is killed. Only ASM is left out. My database instance got killed. So wait for a few seconds. When even though I killed, my database is down. So here automatically my database is back online. Because ASM has that restart capability. ASM will keep on monitoring your database instances. If your database instances got terminated due to network issue or hardware issue or OS issue, your ASM will make sure that your database will be back online automatically. That's where we call it as a Oracle restart server, automatically restart capability in case of standalone with ASM, right? So automatically it came online here. So whereas if I go to my lab one, ps-ef grep s1, so my DB, I'm going to kill that one. So if I kill that one, so my database went down. Here there is no restart capability. DB has to manually connect to database and then bring that database back online. There's no restart concept here. So that is one of the tedious job. Like, assuming that midnight on a weekend, your network crashed, your OS crashed, OS rebooted, and you have a lab one and lab two. In lab two, your database will automatically back online, no need to worry. But whereas in lab one, your database will never back online. You have to manually connect your SQL command prompt and it will be idle. Everything is down. You have to manually do startup. Right, so that otherwise you have to do some small automation, manually start your database. Again, that's scripting, you have to write it, and that's not that easy. Right, so this is your manual work, and because of that, the feature restart, we call it as a Oracle restart server, because your ASM will make sure that your instance will be always up and running. And so this is two types of standalone databases, and we'll be covering in my database course. But coming to RAC, we have RAC one node and RAC database. RAC one node and RAC database. So the difference here is if I go to my, this is my RAC one node database, and these are my RAC databases. So we can check any one of that. Let's say I can first check it to CDB2. I can use srvctl config database -d, my CDB database. This srvctl config will tell me what is my type of database. It's a RAC database. What are my instances? CDB1 and CDB2. Where they are running? They're running on node 1 and node 2. Two node RAC, and it's a RAC database. And whereas this RAC 1 node, I'll set the environment to RAC 1 node. So if I run the same command, srvctl config database -d RAC 1 node, and the type of the database is RAC 1 node, and then this particular RAC 1 node database is running with node 1 and node 2, and the advantages with the RAC 1 node and RAC database will go like this. Let's say I have my, let's take it as a 4 node RAC example. I have 4 node RAC. I have node 1, node 2, node 3, node 4. I have 4 nodes, 4 servers, where my ASM1 is running here, ASM2 is running here, my ASM3 is running here, my ASM4 running here. So let's say my RAC database, my CDB instance 1, CDB instance 2, and my CDB instance 3, and my CDB instance 4. They're all running under this 4 servers. If I configure RAC 1 node, let's say RAC underscore instance 1, RAC underscore instance 2, RAC 1 node underscore instance 3, RAC 1 node underscore instance 4. So in case of this is my RAC database, and this is my RAC one node database. So RAC one node database will be, even though it's a RAC database, but instance will be running on any one node. Like, if it's running on node one, it will be _1, and then other instance will be down. By any reason, your node one goes down. The moment node one goes down, automatically your instance two or instance three will be back online. Your database will be back online here, and other instance will be down. So that's the feature of your RAC one node. RAC one node will be running on any one of the node, and your RAC database will be running on all the RAC nodes. The client can connect to either node 1, or either can connect to node 2, either he can connect to node 3, or he can connect to node 4, any of the RAC database instance. But in case of RAC 1 node, the client can connect only the instance where it's running. So this kind of limiting the resource, like, RAC 1 node, the RAC 1 node database is a small database which used for only some reporting queries. So in that case, there's no much transactions. So in that case, why to unnecessarily run the instances, like, on node 1, node 3, node 4, these instances are like no use. So there's no much transaction and no clients are connecting, only reporting. Then in that case, I can start only one instance so that the reporting can be run on that node 2, and the resource will be used only from the node 2. Remaining all three resources, I can leave it as it is for my other databases. If I start the instances, it's kind of a waste of resources because this database is not much used and only for the reporting. I can run it for only one of the node. For that, I can go ahead and then configure RAC one node. And if it's a critical database and a lot of millions of transactions are running, so again, RAC one node is not that feasible. You have to go with a RAC database. So it has to configure with all the nodes, and client can connect to any one of the node and he can execute his transactions. Right, so that is two types of databases, RAC one node and RAC database. So we'll be covering in this RAC course about this RAC one node and RAC database. All right, so those are your four types of databases. What you can see it in any client location or any industry you work. So you may get to chance to work on these four type of databases. And other than that, there's no other databases in Oracle. All right, so that is about your type of databases. So here is a explanation about that standalone Oracle RAC one node, and RAC database. And what are the advantages, how it can be configured. We can further, we'll discuss in our regular classes. Right. So let's go
Hi,
on
Arjun.
now further. Yeah, go ahead.
Arjun, I'm sorry I joined late today. I'm just asking, do we need to configure this lab session in our local machine, or you also provide this lab access?
Local machine. So the minimum requirement for this course is you should have a hardware of 20 GB RAM, 150 GB hard disk, where you will be setting up lab on your own laptop or desktop using Oracle VirtualBox. All right.
Okay.
All right. So we talked about this installation changes, the 11G to 12C, 12C to 19C, your grid installation, and your database installation. So what are the changes it happened? We discussed that one. And then uh, let's talk about a couple of questions. It's a general one. So it's not related to RAC, or it's not related to uh, standalone or RAC. So I'll just have a discussion open forum. A couple of questions, like, let's say, I'll go here. The very first questions. Okay, let's see first questions. Again, once you continue further classes, you'll understand the tool used for GI or ASM or cluster installation. Again, many people will call it as a different name. Some people will call it as a GI, grid infrastructure. Some people will call it as a ASM. And again, ASM, we have a separate chapter. We're going to discuss more detail on that. Right, that's the Oracle provided storage, automatic storage management, and cluster. Cluster is the combining multiple nodes and make a cluster. So people will call it as a GI software, ASM software, cluster software. After installation, you can call it as a cluster home. You can call it as a ASM home. You can call it as a GI home. Right. So these are like one and same. Which tool we're going to use it to install your GI home or ASM home or cluster home? Right. We have something called grid setup.sh. So this is a tool, Oracle provided tool or the shell script. With help of this, we're going to install my grid home or my Oracle home or my clusterware home. Right, and then second question. The tool used for Oracle home or DB home. Right, so many people again they will call it as a database software, Oracle software. Database software, they will call it as the database home. And Oracle software, they will call it as a Oracle home. Right? You may call it as the Oracle software or Oracle home or database software or database home. So all are referring to one and same. Again, this will be practically, we're going to use this tool and we're going to install the setup. Like let's say if I go here, my grid software, this is my grid software. If I go to that grid software or ASM software, so I have this tool, a grid setup.sh. Right, and then with the help of this tool, what tool we're going to use it for installation of my Oracle home, Oracle software? We have something called run installer. So if I go to my Oracle home here, right here, if I go to any one of 90, let's take 19Z, I have this run installer here. With help of run installer, I'm going to install my, I'm talking about only GUI tools. There are manual silent method. Without this tool also, you can install it using the command line. That's a different story. We can install it in manual method also. And the third question, tool used to create database. So we're going to install grid software and we're going to make that ASM and cluster software or the cluster home. We're going to install Oracle software. That's going to be Oracle home. On top of this Oracle home, we are going to create a database. We're going to use a tool called DBCA, Database Configuration Assistant. With help of this tool, we're going to create a database. So this DBCA, like this grid home will be, the grid software will be on the grid home. So the grid setup tool will be on the grid home. And this run installer tool will be under the Oracle home. And the tool used to create a database, DBCA, that will be under same Oracle home under bin location. If I go to that Oracle home bin ls-l DBCA, so this is your DBCA tool. Right, and then Next question. The tool used to create a disk group, ASM storage, plus data, plus reco, plus archive, plus control, plus redo. So whatever the ASM disk groups or ASM storage, you want to create this ASM storage, what tool we're going to use? We're going to use something called ASMCA. That will be under your grid home bin location. LS-L ASMCA. ASM configuration assistant. With help of this GUI tool, we are going to create this groups. So meaning here, wherever it is having ASM, so I can show you that one .inv plus ASM. So I can run ASM cmd-p lsdg. So I have this data reco OCR. This is your ASM storage. On this storage, you're going to create your databases. Right, and then further couple of questions. Like how this particular ASM storage is created. And again, these are the expected questions you may expect in the interview. So tool used to create ASM disks, ASM disk 1, ASM disk 2, ASM disk 3. So we have something called Oracle ASM library. With help of this Oracle ASM library, we are going to create this ASM disk. Let's say I can run this Oracle ASM list disks. So right now I have disk 1, disk 2, disk 3. 3 disks. With help of these 3 disks, I have created this data OCR and reco Oracle ASM storage. So with help of this Oracle ASM library, we are able to create this ASM disks using this virtual disk. Again, if it's a raw devices and your physical storage, then different story. We'll discuss in our regular classes. You don't need to use this Oracle ASM library if you're using a raw disk or the physical storage or the SAN disk or the true NAS. That's a different type of installation. But now we're going to use a Oracle ASM library for installation or creation of my ASM disk. Right, so let's brief more on that. So whatever this lab 1 here, lab 1 is about standalone without ASM. What we did, installed Oracle Home. We installed Oracle Home. That is under without ASM. That will be a file system. Database is stored under local file system. We installed Oracle Home. After installing Oracle Home, we created a database DB, and that database is running under local file system. Let's say I already showed here. All the data files, all the control files, redo log files, archive log files, everything is stored under local file system. That's for the lab 1. And for the lab 2, Oracle lab 2, installed ASM or GI home. This is ASM or GI home on lab 2. Let's say here. Let's go here. This is your ASM home or the GI home. And followed by we installed Oracle home. 2ls. This is your Oracle home. And after installing Oracle home, we created a test database. And this database, all the data files are stored under your ASM storage. whatever the ASM disk groups, what we see, data, OCR, and RECO, all these are ASM storage. All your data files, like you can see data files here under data disk group. My control files are under data and RECO disk group. Right, that's for lab 1 and lab 2 standalone database. Whereas same thing goes for your RAC database here. You have a ASM1 and you have ASM2. So RAC database will be done like this. It will be your node 1 and node 2. So what we're going to do, install ASM or GI or clusterware home on node 1. Right, the moment I install it on node 1, what it will going to do, automatically it will copy into node 2. I just need to install on node 1. Right, I need to install this ASM GI clusterware home on node 1 and automatically going to copy into node 2. Let's say on node 1 here, where is it here? On node 1, I downloaded the software and I installed the grid software here. Automatically this is copied into my second node here. Same thing, install Oracle Home on node 1. And again, the moment you install Oracle Home on node 1, you'll do the same thing. Automatically it will copy into your node 2. After that, same process. Create RAC or RAC 1 node. You can create RAC or RAC 1 node database. If you create a RAC database, it will be CDB1 and CDB2. It will be having this prefix here, instance 1 and instance 2. Similarly, you have this ASM2, that's the second node. And similarly, you have ASM1, that's the first node. And similarly, you have this CDB instance 2, CDBDB instance 2, prime DB instance 2. Similarly, on node 1, it will be instance 1. Because of that, you will be having the CDB1 and CDB2. That's for the RAC database. If it's a RAC 1 node, you'll be having CDB underscore instance 1 and CDB underscore instance 2. Again, you can change this prefix method, but this is the standard naming convention. It will be either underscore instance 1 and underscore instance 2. Any one of the instance will be running in case of RAC 1 node. In case of RAC, it will be running on both the nodes. Right, that is your other tool, like the tool used to create your ASM disks. And on top of this ASM disks, we created these disk groups. Whatever the disk group we see here, data, OCR, and RECO. These are the disk groups, ASM storage we created with help of this ASM disks. And the question is, which tool we used to create my ASM disk groups? Right, ASMCA. With the help of this ASMCA, I have created these disk groups with the help of these disks. So next question, how many Oracle softwares are installed? How many Oracle softwares are installed on a server? Let's say this is your one software. This is your Oracle grid software. This is your 19C Oracle software. This is your 19C Oracle software under DBM1, DBM2. This is your 12C Oracle software under DBM1. This is your 11G Oracle software and DBM4. These are the different Oracle softwares with a different version or with the same version on a different location. 19C, 19C on DBM1 and DBM2. These are your Oracle softwares you installed it on a server. How many Oracle software are installed on a server? How we can get to know? Right? How we can get to know that one? Read your inventory file. By reading your inventory file, you can able to understand how many Oracle softwares are installed on a server. This is your inventory file. User one app, Vara inventory, contact.xml, inventory.xml. So if I copy that one, cat it on my node 1, server 1, lab 1. On this lab 1, Oracle lab 1, I have this Vara DB 19C home 1. So this is my 19C Oracle software. I know this on lab 1, I've installed only one software. That's a 19C Oracle software. Let's go to lab 2. Lab 2 we have by looking at this one is ASM software installed or the cluster software installed. One is database software installed. By looking at this command itself, I can say minimum 2 softwares are installed on this server. And go ahead and then check the same command. So here, Vara GI 19C home, GI home, Vara DB 19C home. So I have my grid home or clusterware home or ASM home, and I have database home. 2 softwares are installed on this lab 2. Same thing if I go to RAC, either node 1 or node 2, you can check on anywhere. So I can run the same command cat. So what all softwares are installed here? Vara 19C home, that's a grid home. My 12C DBM1 and my 12C DBM2. So we have Oracle, Vara prod, 12C home, 12C home, 2 12C home, one with the Oracle user and one with the Vara prod user. You can literally go to that location CD and do ls. This is your 12C Oracle home running under Oracle user, and there's a Vara prod. Again, go to that location as well and do ls, and you have the same 19C, same 12C software, 2 12C software, one with Oracle user, one with Vara prod user. And the same thing here, 2 softwares, Oracle user, 19C, 19C. One is a DBM1 and other is a DBM2. So if I go to 19C, do ls, this is your 19C software. Same thing, you can go to DBM2, do ls, that's your DBM2 19C. And we have this grid software. This is a 12C grid software, the old grid software, 12C grid software, and we upgraded to 19C grid. So these are the softwares are installed on this node 1. Same thing goes for your node 2 as well. So the only fact or only truth to identify, to answer this question, how many Oracle softwares are installed, you have to read your inventory file. Then only you will get to know what all softwares are installed. Otherwise, if you are new to project, you joined any organization, there is no way. If you don't maintain your proper inventory file, if manually somebody went into this inventory file and wrongly updated some extra entries here, that's the wrong thing. You're going to mess up the things. Because anyone joins a new project or new organization, only truth or fact is you have to rely on this inventory file. If you mess up your inventory file and you manually update or modify wrong entries in the inventory file, ideally not recommended. If you do it, nobody can help you. And I can assume I'm the new, I joined the project, and then this server is rebooted. Database is not started. I need to first understand what all softwares are installed on this server. Only fact is I can check this inventory file and I can see what all softwares are installed. And based upon that, I can go ahead and start my databases. Great, that is your inventory file.
What is the difference between Aura tab and inventory file?
Please stand by. I'm going to explain that. Right. Next question. I know, like, we got to know now. In order to get it out, what all the softwares are installed, I need to check this inventory file. Where is my inventory file? And on what basis I told this is my inventory file? That's the next question. How to find out where is the inventory location so that I can read that inventory file and then I can understand. So this is your standard etc inst.loc. That's going to tell you where is your inventory. Inventory location is user and app inventory. So inside that user and app inventory, context.xml, inventory.xml. And next question is, how many databases are created on a server? Right now, let's say these are the software you installed, but did you created any database on this? Right? You might have just created a software. You have not created any databases. Right? That is why I told here, install Oracle Home. After that, create a database. Install GI Home, install Oracle Home. After that, create a database. You might have just created a software. You installed a software, but not created any databases. So now I need to find out how many databases are created on a server. How many databases are created on a server? You have to check your etc Oracle file. So if I go to my node 1, lab 1, if I do cat Oracle file, this cat etc Oracle file will tell you this particular lab 1 server has a DevDB database created under this 19C Oracle Home. Right? So let's go to second one, cat/etc Oracle. This particular lab 2 server has plus ASM. ASM is created and testDB database is created. If I go to my node 1, RAC node 1, cat etc Oracle, this particular etc Oracle file will tell me plus ASM and my CDB, my RAC 19C, RAC 12C. This is a single truth or fact. Your Oracle file will tell you what all the databases are created. So right now, let's take this the scenario. I joined the new organization, I joined the new project, and then I logged into this server and I'm going to run this command ps-f grep s1, right? Nothing is running. Oh, is it a brand new server where no databases are created here? I can assume quickly that, okay, this is a brand new server where they have installed only ASM and they have not created any database. There may be a possibility or chances I can assume like that, but that's not the fact. Next question is I need to go ahead and then check. Okay, this is the lab node 1 server where ASM is running. So I need to understand what all the ASM softwares are installed. So I can go ahead and then cat my inventory file first. So the moment I do cat my inventory file, I'll get to know what all the softwares are installed here. I'll go here and then do cat. Okay, there are many softwares are installed, 12C, 19C, Gridome, and even in 19C, DBOM1, DBOM2, and even 12C, Oracle 12C Home and Pro 12C Home. Many softwares are installed, fair enough. And quickly I can go and then cat my etc Oracle file. My Oracle file will tell me, oh, there are so many databases are created, but none of them are running here at the moment. If I see, nothing is running here, but there are many databases are created on this server. Only truth or fact is to tell you how many databases are created on a server. You have to maintain proper Oracle file. If you wrongly mess up this Oracle file or update like something, you can VI this Oracle file. You can add a database called Malik and 19C Oracle Home. That's a wrong thing. Ideally, we should not manually edit or modify wrong entries on the Oracle file, because anyone joins or any single point of truth is your Oracle file tell you how many databases are created on a server. And the next one is how many databases are running on a server. Right now, if I do ps-f grep s1, nothing is running here. If I run the same command on the node 2, there's so many database instances are running here. So only single fact of truth is you have to run this command, identify how many databases are running or how many instances are running. On a server, you have to run this ps-f-grep-s1 that will tell you how many databases or instances are running on that particular server. So right now here looking at node 1, nothing is running here. They might be configured 10, 20, 30 databases here, 30 instances here, but at this moment, nothing is running here. How to find out how many databases are configured? You have to look at your oratab file. Oratab file will tell you how many databases are configured or installed on a server. Running is different or installation is different. Installation is actually they installed on the server, but database might be down for some maintenance. You have to run this ps-f-grep-s1 command to validate whether it is running or not. The next question is how a DBA can connect to database, or how you are going to connect to database, any database. Right, let's say here take this RAC. What you're going to do, you have to first type this ps-grep-s1. You got these many list entries here, database. You have to understand which database you want to connect. You want to connect to CDB2. Who is the owner of this CDB2? Right? So this is Oracle is the owner. You want to connect to this oraprod2. Who is the owner for this one? You have to look for that oraprod. So you have to first understand who is the owner of that. And then you have to switch SU Oracle or SU oraprod. Who is the owner? First understand by running this command, and followed by you have to log into that one. Let's say I want to connect to this CDB2. So I have to log into Oracle user then. SU Oracle. Right now you logged into Oracle. After that you have to run this .oranv. After this running .oranv, it will ask what is the SID. I want to connect to this CDB2. After setting the environment to that one, you run this env grep ora. That will tell you your CDB, your Oracle base and Oracle home. So all are connected here. All are like exported here. Now you can go ahead and then do SQL plus /SDBA. You'll be connected to that database instance. Similarly, if you want to connect to other database, oraprod one. So now you want to connect to this oraprod2. And who is the owner for this one? For this, it's a oraprod. You have to log into that particular user. And then same process, .oranv. Run your oraprod instance too. And then verify your environmental variables are set properly. Oraprod2, Oracle base, Oracle home. And go ahead and run your SQL plus SSDBA. And that is your how a DBA can connect to a database instance or database. And the next question is how DBA can connect to ASM instance, or how to connect your ASM instance. Same process. You have to understand who is the owner first. Whether it's a RAC or standalone doesn't matter. ps-f-grep-s1, your ASM2 is running here. Who is the owner for that? Owner is Oracle. Log into that Oracle owner. After you log into that Oracle owner, again set the environment. Setting the environment, it will ask SID. What's the SID? It's a plus ASM2. And then again verify your environmental variable running this command. Your plus ASM2, Oracle base, Oracle home. This is plus ASM2 if you're running from node 2. If you're running from node 1, ps-f-grep-s1, the same process. It will tell you your ASM is plus ASM1. Owner is Oracle. Log into Oracle and run your .oranv and plus ASM1 and verify your environment. Plus ASM1, Oracle base, Oracle home. And go ahead and then run. They're going to connect to your ASM instance. And same thing, run it on second node. They're going to connect to your ASM instance. So this will be your SQL plus /s sysasm. Whereas for database, it will be SQL plus /s sysdba. For database, it's assist DBA. For ASM, it's assist ASM. That's your how you're gonna connect your ASM instance. And then next question is how to connect your ASM storage. Right? We talked about here this ASM storage, data, OCR, RICO. How to connect to that ASM storage. For that, again, same process. ps-app grep smon, su oracle, dot ora nv, set the environment to plus ASM. So whatever we did here. So everything should be set to plus ASM and ASM Oracle base, ASM home. The same thing verify on the second node as well. But after you setting this one, you're gonna run this command ASM CMD, ASM command line -p. Right, that's gonna take you to ASM command line LSDG. So that will be plus data plus RICO. If I run the same command on the second node here, first node, LSDG, that will be a plus data plus RICO on your RAC node 1 and node 2. If I go to my Oracle lab 2 plus ASM env grep capital ora ASM CMD -p LSDG. So plus data plus OCR plus RICO. So if you go to plus data LSFNL, you have only test database here. But whereas on your RAC database, you know like how many databases are running here. If I go to my plus data, under that, if I do LSFNL, there's so many databases. CDB database, 19C, Waraprod, PrimeDB, RAC12C, RAC1 node single. So many databases. The respective directories are created over there. Right, that is your ASM storage, how you're gonna connect. Right, so that is your basics, right? Whatever I talked about is the basics as a DBA. This is the things what we're gonna do it on daily basis. How you're gonna connect to ASM, how you're gonna connect to a database, how you're gonna connect to your ASM storage, and then how you're gonna manage your running databases, running instances, how you can understand what all the databases are created, what are the softwares are installed on a server. And then based upon that, we're gonna continue further administration of my database, my clusterware, and other resources. All right, I'll take a pause here for a minute if anyone has any questions so far. It may be anything or anything I can so far or anything related to the course. Anyone has any questions so far? All right.
Hello.
Yep.
So I install all single binary, single software and single database. I can and install all single software, multiple database.
Right.
Or I can install all software and multiple database. Which
Right.
one is best practice?
It's a one-to-one. It should be one software, one database should be installed. So reason behind that is, let's say I have a server and in this server I have installed my ASM. I have installed my Oracle home. Let's say Oracle home 19C Oracle home 19C underscore DB home DB home underscore 1. So I install this one software, and in this software I created a database called dev. I created a database called test. I created a database called UAT. One single software, Oracle software, and that software I created multiple databases. Again, we know that development team will do a lot of scripting and development tasks, and testing team will do a lot of batch processing, queries, and stress test and all those things. UAT again, the load and all. So for some reason, because of the developer code, this dev database hit a bug, some Oracle bug, Oracle issue. After that bug, a DBA, we work with Oracle support. Oracle support will provide us a patch 1111. They will ask us to apply this patch on this Oracle home. In order to apply this patch and this Oracle home, you have to shut down your dev database, you have to shut down your UAT, and you have to shut down your test. So you have to ask your testing team and UAT team and get a downtime and apply this patch on the Oracle home. So unnecessarily to fix that development issue, you have to get a downtime for your development, sorry, your test and UAT. And after you apply that patch on the Oracle home, and your test database and UAT database may be hitting some issue because of this patch, which is leading some issue on your UAT and test database. Again, you have to work with Oracle support. That's a tedious. So instead of that, if you created your environment like I have Oracle home 1, my dev database is running. I have my Oracle home 2, where my test database is running. I have my Oracle home 3, where my UAT database is running. Fair enough, 3 Oracle home, 3 database are running. And if I hit this bug here, I'll work with Oracle support. I'll get a patch 1111, and then I'll shut down my development database. I apply the patch and development Oracle home, and I start my development database. I'm not going to impact anything on my test and UAT. Those will be up and running while I'm applying the patch on my development database. So you can avoid unnecessary downtime, dependencies, and in order to fix one database issue, you are going to break the other database if you are going with the one single Oracle home. So always best practice is go with one Oracle home and one database. All right.
Only
do you have
I have one question. Sometimes we have to make changes in a parameter file. So in RAC environment, how can we changes manually in P file? Because here SP file is present in shared storage.
There is nothing called a P file. Always your database has to run with a SP file. Your database has to run with a SP file. So again, if you understood your basics, we have a P file, that's a text file, and we have a SP file, that's a binary file. So we always recommend or best practice, your database has to run with your SP file. So what happens in case of RAC? You have a database instance 1 and database instance 2. Two database instance, both are using your shared storage, and the shared storage have your SP file. You have a shared storage as SP file, and default, if you understood the basics in your database, we have a parameter called static and parameter called dynamic. So if it's a dynamic, we can change it. Let's say dynamic parameter, one parameter, open underscore cursor is a dynamic parameter. So what I want to change? I want to change it for this RAC database. I can use command alter system set open cursor. Let's say it is a 300 value. I'm going to change it to 350. The old value is, let's assume it's a 300. I want to increase it to 350. You want to increase to 350, fair enough. Where you want to increase? You want to increase it on all the both the nodes, and it's a dynamic parameter. You want to increase this parameter on both the nodes. Alter system set open cursor 350. Give me a second, I'll put for a charging. Right. So once you set it to 350, where you want to set it? You want to set it on both the instances, or you want to set it on only one instances? That's your instances star, meaning I want to set it on both instances. No, I don't want to set it on both instances. I want to set it on only devdb1. I want to set it on only devdb2. And you can specify where you want to set it. Scope, Where you want to set it? I want to set it on SP file. I want to set it on SP file. Right, you are going to modify instance specific, or you are going to modify all the instance specific, and you can go and then define it and then bounce that particular instance, and the new value will be reflected on that particular parameter. There's no concept of a P file at all. We never ever recommend to go with a P file. Always your database has to run with SP file so that you can make use of your dynamic parameters. And same thing applicable for your static parameter. Static parameter also, you're going to set the same story. Instance equal to devdb1 or devdb2, scope equal to SP file, and bounce your that particular respective database. So this is for your a dynamic parameter. So dynamic parameter, we always recommend to go with the scope equal to both, and we never recommend to go with SP file. So always go with the both, then immediately it's gonna reflect and immediately it's gonna be activated on your database. If it's a static, you have to go with the SP file, like let's say processes. Processes is a parameter which is a static parameter. So you cannot do scope equal to both here. So you have to go with 300 to make it to 350. And then scope equal to SP file. You have to bounce your database instances in order to take it effect. Right, it's same as whatever, how you're going to handle it in your standalone. Same thing applicable for your rack, but only one extra entry will come. Instances where you want to change. Only on one instance, star is going to be like both instances. All right. Let's quickly talk on one more concept. That's a daemons, or the processes. So in the cluster, in the rack, we have many daemons or processes, which are cluster resources, local resources. Some of them are cluster resources, runs across cluster. Some of our local resources runs on that particular local node. So I'm not going to go deep into that. So in regular classes, we will discuss more on that. Let's say your scan. Let's say here on this node 1, node 2, plus ASM2, CRSETL stat resource -t. So there are so many cluster resources and there are so many local resources. Local resources runs on that particular local node, and whenever that node goes down, that local resource will be down. And we have this cluster resource runs on all the cluster node, and whenever there's a, for example, the scan one, and then there's a VIPs here, the scan VIPs. Right now, scan 1 running on node 2, node 2, node 2. All the scans are running on node 2 now here. The moment node 1, node 2 goes down, all the scan will go into my node 1. Same thing goes for your scan listener. Scan listener will run under particular all the cluster nodes. The moment node goes down, all this cluster resource will go into that other existing node. The cluster resources can run on any of the cluster nodes. For example, your scan VIP, your scan listener, and your local resources, like local resources, your node IP or your whatever the local ASM instance or the local listener running on that particular node. So if this node goes down, that particular entire resource will go down. So you can go and then check each of individual nodes. CRSCTL stat resource -t -init will tell -init will tell on this node what are the cluster resources are running here. And same command, if I run it on the node 1, so what are the cluster resources are running on that node 2. And if you remove this init, that will list out your all the cluster wide what are the cluster resource, and all the cluster wide what are the local resource. Local resource is like listener locally running on node 1 and node 2. If the node 1 goes down, that listener will go down. And similarly, your network running on node 1 and node 2. If the node 1 goes down, that node 1 network will be down. So those are like local resource and the cluster resource. So cluster resource can be accessed by any of the cluster node, and there are few cluster resource. Whenever the node fail over, automatically going to fail over to other cluster nodes. For example, your VIPs, your scan VIPs, your scan listener, they're going to fail over to other cluster nodes. So all this cluster resource and local resource has the respective daemons. The daemons or processes versus your resources. So whatever I talked about resource, that's a cluster wide resources, the services. And this cluster resource has the respective daemons or the process at your OS level. Right? What that meaning? Let's say I have my cluster interconnect, CRF, CRSD, CSSD, CSSD monitor, CTSSD, Diskmon, SFS driver, EVMD, GIPCD, GPNPD, MDNSD, storage. All these cluster resource has the respective OS level daemons or OS level processes. You can go ahead and do ps-f grep d.bin. The d.bin will tell you OHSD, Ora agent, MDNSD, EVMD, GPNPD, GIPCD, CSSD monitor, CSSD agent. So all your OS processes or OS daemons are associated to your cluster resources. Right? That's a mapping. All your cluster resource has its respective OS process, and the respective OS process ID will be running under each cluster node. This is on your node 1. Similarly, on node 2, you go and then do this CRCTL stat resource -t -init, all this cluster resource on second node. And the moment you do ps-f grep d.bin, so all the same resource at the OS side, or the process or the daemons at OS side, it has a respective process ID and then running at OS side. The moment you shut down that cluster resource, the respective OS process will be removed here. Or somebody kill this OS process, your cluster resource will go down. So that's all like mutually interconnected, your cluster level resource and the OS level daemons. And if you kill at the OS level daemons, or you can stop the cluster resource, both will be get stopped and either way. Right. So couple of, this is your cluster resource versus local resource, and the OS daemons versus cluster resource. And then the cluster and database can be managed using CRSCTL versus your SRVCTL. So CRSCTL is a cluster control, CRSCTL is a server control. Most of your cluster activity we can use a CRSCTL, and most of the times database activity we can go with the SRVCTL. So again, this cluster control and server control can be run with the root user, can be run with the Oracle user, and it all comes based upon practice. Let's say here I'm gonna use ps-f grep smon, and we'll get to know my ASM is running with Oracle user. Right now I'm at a root user. I can do CRCTL. I'm going to set the environment to plus ASM2 env grep capital Ora plus ASM2 Oracle base, Oracle home. I can use crctl stat resource -t -init. I can list out all the cluster resources. Same thing if I log into Oracle user. Oracle user is nothing but your grid user is Oracle. I can set the environment plus asm 2. I can run the same command. Right? I can get the same result. So there is no hard and fast rule which command to run with which user. It's all comes upon your based upon experience and how much you practice it. Right now, let's say I'm at Oracle user who is the owner of my grid. Right now, a plus ASM2 owned by Oracle user. Right now, I'm connected to the Oracle user. Now I'm trying to do SRCTL, so CRCTL stop CRS with the force. So it says insufficient privilege. I cannot stop my cluster with the Oracle user. So I'm gonna do this .orinv plus ASM2 CRSCTL start or the stop CRS -f. So I can do stop with a root user. I can do that one. So the meaning here, root or Oracle, anybody can run. But again, certain command can be allowed with root user, and most of the commands are allowed with the root and Oracle user. And you have to practice and then understand which command to be run with which user, so that you can easily run those commands on fly. Otherwise, like sometimes you can see insufficient privileges, Oracle cannot run this command, and it has to be run with only root user. All those errors you can get it. Alright, it's getting stopped. It's stopping all the services or resources. One that is done, then your entire node 2 will be down. Alright, so I'll take a pause here. I'm gonna stop it for today. Let's continue in our actual classes with the further topics. We'll start it from the scratch, starting from the installation, and we'll understand each and every concept in details. But yeah,
Malik,
before we wrap it up, any questions, guys?
yeah, one last question. What is the meaning of online, offline, and what we do when the status is online, offline?
Online and offline, again, we have two things. One is a target, one is a state. Your state will be, sometimes it may be online or sometimes it may be offline. The state is whether it's running or not. The target is whether it's configured or not. That's the meaning. Target is whether that service is configured on that node or not. State, whether it's up or down. It varies. It varies whether you're referring to state column or whether it's referring to target column. Target column online meaning the resource is configured on that node, and offline meaning that resource is not configured on that node. The state meaning whether that service is up or not on that particular node.
If the state is online, offline, so then we need to start that service.
Right. If it's offline, you can go ahead and start it.
Okay. And what is the difference between the start CRS and a start cluster?
Start cluster.
Yeah. What is the difference between?
There is nothing called start cluster. It will support
Uh,
stop cluster, but in order to do a start cluster, there's a dependence OHST has to be started. Again, that's too early. There are too many things before going to start cluster and all. We need to understand. There's a very basic thing. You have the underlying bottom OHST. On top of this OHST, you have your ASM. On top of ASM, you have your database. And again, same thing on the other node, you have OHSD. On top of the OHSD, you have ASM. On top of ASM, you have database. And then this OHSD will run with the CRS. And again, this OHSD will run with the CRS. So there's a different concept together: start cluster, stop cluster, start OHSD, stop OHSD. So we'll discuss in our regular classes. It's not just one single definition here. CRSCTL, stop HAS, CRSCTL, stop CRS, CRSCTL, stop cluster. So when you use a stop cluster, you have to use a keyword called all. Without that, it will not support. So what's the meaning of HAS? What's the meaning of CRS? What's the meaning of cluster? Same thing. Instead of stop, you can do start HAS. You can do start CRS. You can do start cluster. So this is not that easy one definition I can give you. So first you have to understand what is the hierarchy, and then you can understand when to use this stop cluster all. In order to use this stop cluster all, your HAS has to be up. Then only you can able to do this stop cluster and start cluster. If your HAS is not on, you cannot do this stop cluster all. And again, if you do start cluster and stop cluster, you have to use a keyword called all. Without all, it will not work. All right, yeah, I will
Thanks.
discuss in our regular classes, guys. Please stand by for that. All right, I'm gonna pause it for now, pause it for today. Let's continue on our regular weekend, starting from next Saturday. We'll start it from the scratch, starting from the installation, and we'll go deep dive on each and every concept, and we'll understand in details each topics. All right, thanks everyone, guys. Thanks for joining, and have a great weekend. Thank you.